guess good morning, everyone. I don't know when you're watching this. I'm recording in the morning, so we're going to go with that. My name is Nick Koval, and I'm a senior professional services engineer with Jamf. I'm here today to talk to you about an introduction to regular expressions. But a little, I guess, boring fact about myself, I'm not a fan of that picture. So let's change it. Another boring fact about myself, I don't actually own this hat. It came from a ride shop at the end of the ride, my honeymoon. Put that on. My wife was like, "Hey, turn around, take a picture." Been back there many times. Still don't own that hat. So, anyways, much prefer that picture though. So, what are we here to talk about? Well, we're here today to talk about regular expressions. We're going to talk about what they are. Why should we bother using them? And then hopefully, if I can answer that question to your satisfaction and you keep watching, we'll go through the process of building regular expressions, figure out where we can use them, and then give you some additional resources to kind of continue your learning journey on regular expressions. First off, what is a regular expression? Well, according to Wikipedia, regular expression is a sequence of characters that specifies a search pattern in text. I want to focus on this idea of a pattern. If I put up, for instance, this pattern, H2O, your brain immediately looks at that pattern and goes, oh, that's water. Because you recognize H2O, honestly, from years of marketing and everything else with squirt guns and water balloons and water parks and the whole nine yards, to say, hey, this is water. So your brain is kind of hardwired at this point to search for the pattern H2O and turn it into water wherever it sees it. That's similar to what we use regular expressions for. Now, for a less easy example, I'll give you the one for the chemistry nerds. Anybody? Caffeine. So yeah, hopefully you had some of this morning to help wake up. If you're not a caffeine person, that's great. Congratulations. I'm envious of you. I still need a second or a third cup today. But now that we understand a little bit about pattern recognition, let's jump into what are regular expressions. Well, realistically, they're just a way for us to describe a pattern of characters that make up a string. Just like H2O was a way for us to describe two hydrogens and one oxygen, a regular expression is just a way for us to say, hey, this is a way that this string works, or this is how these characters are organized in a specific order. So now we know what they are. Why should we bother with regular expressions? And this one's kind of a little trickier, right? Let's take a look at an example. So on the left-hand side, I've got my terminal window. On the right-hand side, I have my script in VI. And I know some of you are not fans of VI, but VI is a very minimalistic script editor or minimalistic text editor. So it allows me to put a lot more stuff on the screen without having all the overhead of items below it. So this simple script is going to prompt us to enter some input. It's going to evaluate that input with an if statement and then take action depending on what it sees the input as. Let's run it. Let's see how it works. Okay, let's make it executable first and then run it and see how it works. All right, so there's our prompt. We'll type in true and hey, look, everything works. Great, awesome. Well, it works for me, right? So let's clear this input out and let's give it to somebody else. So we'll pass it off, give it to the next person in the organization. There we go. And ask them to run it. Well, when they run it, there we go. They go in and they type in true. Well, they did do this in the right spirit of things, correct? Like they entered the word true. It's just that they entered it with a capital T. But because our input is looking for lowercase t, it says, nope, that wasn't what I was looking for. Well, okay, we can fix that, right? So we can go into our script and we can add a compound if statement to look for either of those two things. All right, cool, let's do that. So then we'll save it. And once we save it, then we'll go back and make sure it's executable again, and we'll run it. And they enter true. Sweet, that works. Next question, does it still work for us? Yep, totally fine. Cool, let's pass it to a third person in the office and see how they do with it. Okay, how about a fourth, just out of curiosity? Oh, come on, who types like that? All right, so the bottom line is we could go through the process of creating a compound if statement to represent true. But let's do a little bit of math and figure out how complex this statement's going to be. Well, if we take a look, with true, there are 4 characters in the word true, and each character has an upper and a lowercase option. So that combined with the fact that we did have that one person that just entered a T, right? And that's one character, but it still has an upper and lowercase option. And then I'm reasonably certain, working in computer science, that you may find somebody who just uses 1 and goes, oh, yeah, it's a Boolean. So I'm just going to enter 1 for true. Well, they're not wrong, but at the same time, it's something we have to account for. So if we add all that up, what we end up with is 19 different options for the word true. Okay. I mean, that's not a tricky compound if statement. I could probably write that, right? Well, what about false? Well, if we look at false, false is 2 to the 5th, because there are 5 letters in false, plus 2 to the 1st, plus 1. So there's 35 different options for false. Okay, that's getting a little stickier. But what about phone numbers? What if I want to validate a phone number? Well, according to Wikipedia, we're sitting at about 7,950,000,000 phone numbers and climbing. That's a compound if statement that's not going to work in any scripting language that I'm aware of. Okay, well, we won't do phones. What about just IPv4s? Thankfully, there's a maximum, right, to IPv4 addresses. But unfortunately, that maximum is 4,294,967,296 addresses. Which again, if I go to somebody and I say, hey, this is a 4 billion line script, they're going to look at me like I'm insane. This is where regular expressions come in, and this is actually where they shine, because I don't have to create something that's this long to accomplish the task. So, how do we build a regular expression? Well, what I'm going to do is I'm going to borrow from one of my resources that you'll see later, which is RegEx 101, which is a website that actually helps you test regular expressions. So at the top of the screen up here, you'll see this box. That box that's there, I guess, over there, somewhere, I don't know. Wherever it is, according to my video. That box at the top is where we're going to type in our regular expressions. Below, I've got a whole bunch of test strings. And we'll see how those test strings, or how the regular expression we type in, evaluates with those test strings. So, most basic thing that we can type in is just a T. And when we type in our T, you'll see that a lot of these strings have an uppercase T in them. We're not talking about what position that uppercase T is in. We're not talking about anything beyond the fact that it has an uppercase T. So when we have a regular expression with just an item in there, it's looking for that one thing. In this case, an uppercase T. Well, that takes us to the first set of special characters that I want to introduce to you. And those are braces. So those square braces that we typically see. And what we're going to do with those square braces is we are going to enclose an uppercase and a lowercase t in those square braces. And that makes a list of characters. What this tells a regular expression is that in this spot, this one location, there can be either an uppercase T or a lowercase t. So very simply, we're saying, hey, show me all of the strings that have either an uppercase or a lowercase t in them. So we see all of our trues, we see all of our uppercase and lowercase options as far as the single t by itself. And then you'll see we include cat and tree and atom in there because those also contain an upper or a lowercase t. All right, so next, let's talk about another set of special characters. And those special characters are going to be the caret and the $sign. The caret represents the beginning of a string, where the $sign represents the end of a string. So what we've told our regular expression now is our string is exactly one character long. And that string can have either the uppercase t or the lowercase t in it, and that's it, nothing else. Now, because of the square brackets that we've put in here, it's a set of characters. So I could, if I wanted to, include the 1 in that set of characters, and it would allow for an uppercase t, a lowercase t, or the value 1. But because I'm going to leverage the uppercase and lowercase t as part of true later, I'm going to put this a little bit differently. I'm going to break the 1 out and introduce an or character, which is the pipe. So now if I type this in, I get 1 or uppercase or lowercase t, but you see there's a problem. Somehow cat got pulled into the mix. And that's because when we read this string, we read it as the beginning of the string, the number 1, or the letter T, upper or lowercase, end of string. The problem is that a regular expression interprets this as start of string 1 or any string that ends in an upper or lowercase t. Notice street doesn't count because that ends in a period, but cat does because cat ends in a lowercase t. So we fix this by using parentheses. And parentheses are sometimes referred to as capture groups. So we're going to create a capture group in here with parentheses, which is we're going to say beginning of string, something here in the center, end of string. And in this case, we're saying the something here in the center is the value 1 or upper or lowercase t. All right, so we're getting somewhere now because now we can start adding in our R, U, and E characters. And the first way we would do this is we would go in and simply say 1 or uppercase T, lowercase t, uppercase R, lowercase U, uppercase E, lowercase e. You'll notice that the order that I put them inside of the individual set doesn't matter. What matters is the orders of those sets. T has to come first, followed by R, followed by U, followed by E. Else it's not true. But inside of each of the sets, you'll notice the U's are reversed compared to the rest of them. And that's because it doesn't matter what the order is in the set. So I can put the uppercase U or the lowercase u first. It doesn't matter. It means the same thing. Now, this gave us all of the different variations for true, and it also gave us the value 1. The problem is it doesn't also cover the uppercase and lowercase t by itself. To do that, I need to give you another special character, the question mark. And we're going to use the question mark to make a character optional. The easiest way to think about it is that a question mark allows for 0 or 1 of those particular items. So in this case, we're going to put a capture group, another set of parentheses, around R, U, and E. When we do that, we put a question mark after that, and it says R, U, and E are optional. So there's going to either be a 1 or there's going to be an uppercase and a lowercase t. If there's an R after it, because the R is an optional character, it has to be followed by U and E. That whole group of R, U, and E is optional, not the letters by themselves. So now we have something that meets all 19 of our conditions. Excellent. Now, for those of you who are looking for a real simple, just here are the different notable characters out there, I've got this in here so you can take a screen grab of it. It's not something that I'm going to go through as part of the demos, but you'll see some of these characters later on when we're using this inside of Jamf Pro or inside of the command line. It's also in your handouts. Cool. So let's go back to our script, and you'll notice on the left-hand side, we still have our terminal window. On the right-hand side, we've now replaced our input, our compound input, with a regular expression. And to make that work, our double equals has now changed to an equals followed by a tilde character. The other thing of note is that the regular expression is not put in quotation marks. What this now means is, does input, whatever the user enters, does it match the following pattern? And that pattern is defined by a regular expression. Cool, so let's run it, see if it does. Well, so we run our script, and yes, if you type weirdly, it still works. If you type a 1, it still works. If you type everything uppercase, it still works. So all 19 of those values work inside of that one line. It may be a little harder to read, but it's a lot quicker than using all 19 of those values. All right, so hopefully that's given you an idea of the value of a regular expression and how to build it. Now, let's find out where we can use regular expressions. Well, number one, we can use regular expressions inside of some of the command line tools, the development tools, and the scripting apps that we have available to us. But if we switch out of this, we can also go into our Jamf Pro server and use them in advanced searches and smart groups. Let's take a look first at some of the command line tools. I want to talk first about a tool called Find. Find can be used to find items on your hard drive with regular expressions. So in our example here, we're going to use Find to locate all of the files that end in .weblog. For those of you who don't know what a web location file is, if you simply grab a URL in your URL bar and drag it to your desktop, that becomes a weblog file. And that weblog file, it's just a plist. So we're going to peel it open with plist buddy and pull out the URL that happens to be in there, ignoring any errors. So how do we do that? Well, first, let's talk a little bit more about Find. So for those of you who didn't or did know this, whichever way it goes, you can right-click on Find and select Open Man Page, and it will give you the man page for Find. And this is how you can find out how to use regular expressions with Find. So what we're going to do is we're going to tell Find to dig inside of our users folder, looking for a regular expression, and take that regular expression, whatever it finds using that regular expression, pass it over to plist buddy, and print out the URL from there. Where's that regular expression hiding? Well, to make it a little bit easier for you, right here is our regular expression. And we're saying any file name that ends in period WEBLOC. Recognize the $ as the end of string? Yeah, that's our regular expression. All right, so if we run this, and in my case, it's going to give us a lot of output, simply because this is how I store all of my bookmarks, so that I can open them in whatever web browser I'm using that particular day. You'll see that there's Apple, there's the developer page for Jamf, there is how to get the current user in Mac OS from Armin Briegel's site, Scripting OS 10. There's the RegEx 101 page, and also there's a link to YouTube that Bill Smith did for the Penn State Mac Admins Conference several years ago about regular expressions. All of those, well, the majority of those links you'll see in the links at the end of this presentation. All right, so let's take a look at another tool in the command line. And this tool that we're going to use is grep. Grep actually is built to use regular expressions. So in this case, I'm going to use plistbuddy again to print out my global preferences for my user account. And then I'm going to use grep to look for lines that end in true or false with a regular expression. So if we run this, there's print, and then we're passing that data off to grep. And again, our regular expression is right here. You'll notice that I'm using grep-E. Some command line tools require that you use that to access the full capabilities of regular expressions. Again, for more data on that, refer to the man page for that command line tool. But again, what we're looking for are lines that end in true or false. So hopefully you're recognizing both the $, that's the end character, as well as our capture group for true or false. Let's run it and see what happens. Well, there we go. There's all of the lines inside of my global preferences that contain the word true or false at the very end of the line. You'll see, the number one thing that's in there is that NS automatic quote substitution enabled is set to false. Why? Because smart quotes are not your friend when you're writing scripts, ever. All right, so enough on that soapbox. Where can we see regular expressions used in Jamf Pro? With regular expressions in Jamf Pro, what we're going to do is create just a normal search. And we're looking for computers whose name does not match MD- or ML- followed by the serial number. Now, I know some of you may be asking, why are we talking about computer names when it's not a good idea to have a naming convention anymore? Well, some of you have managed to get away from naming conventions, but not all of us. There are still some organizations out there that rely on a naming convention. And this is an easy way for you to check to see if you've got computers in your fleet that aren't aligning with your naming convention. So let's take a look. We're going to go into computers. We're going to go into new advanced computer search. We'll save it. We'll call it good computers with bad names. Then we're going to go into our criteria and select the computer name criteria. Then we're going to choose does not match and type in our regular expression. Now, if that's a little difficult to read for you, I apologize. I've got it down at the bottom of the slide. So again, we're using our caret and our $sign to represent the beginning and end of our string. We've got a capital M followed by either a D or an L. Again, remember, brackets, that's a set of characters, followed by a dash. And then we've got another set in here that are the letters A to Z and 0 to 9, followed by some curly braces with the numbers 8, 14. What that means is repeat A to Z or 0 to 9 8 to 14 times. Apple defines a serial number as a set of characters A to Z, 0 to 9, so alphanumerics, that can be anywhere from 8 to 14 characters long. So that's why our query for the serial number here, or our regular expression rather, for the serial number here is A to Z or 0 to 9. All of those characters are allowed, just not spaces or special characters, 8 to 14 times. So 9, 10, 11 characters would all fall into this category. Now, I'm not going to actually show you the results of this search because it matches everything in my database because I have totally made this up. But you can run this in yours as an advanced computer search and see what you get. All right, next, let's take another example here. There we go. And in this case, we're going to look at a mobile device cost center that matches the form 2 digits followed by a period followed by 3 to 5 lowercase letters. Now, what's special about this example is using an extension attribute that doesn't exist yet. So let's go create our extension attribute to start with. We'll go into settings, we'll go to device management, and then extension attributes. Under there, we'll make a new one and we'll call it cost center. Now, this is going to be in the purchasing display section, and it's going to be a string. So then we'll go to devices and we'll create a new device smart group. And that smart group we'll call valid cost center. We'll go to criteria, we'll hit add, show our advanced criteria, and then scroll down until we find cost center. Now the cost center in here, because it's a new string value, it automatically allows us to leverage that matches regex capability. This is something that's been in Jamf Pro for a number of years now. It started off with just allowing you to do it for mobile devices in, I want to say, 10.19. And then in newer versions, it added the ability for regular expressions to be used in computers as well. So it's been around for a while, and there's a good chance that you have it. Now, what is this regular expression? Again, if it's hard to read in that section there in the video, you'll see down at the bottom that I'm using start of string, the numbers 0 to 9, and again, curly braces with the number 2 inside to say there have to be exactly 2 digits. 1 isn't going to cut it. Anything above 2 is not going to cut it. It's exactly 2 digits. Followed by a backslash period. What that says is treat the period as a normal character. Don't try to turn it into something else. Followed by lowercase a to z, 3 to 5 times, and then the end of string. All right, hopefully that's giving you some ideas of where you can leverage regular expressions in your environment. Where can you find more information? Where can I get continuing education, if you will? So a couple of resources that I want to make you aware of. We have an article called Using Regex with Smart Groups and Advanced Searches. That's a Jamf technical article that tells you how you can leverage it and some of the characters that Jamf Pro allows for in the regular expression query. As I mentioned, I also have a link here to William Smith's An Introduction to Regex. He did a great, I think it was an hour-long presentation one year for Mac admins, one of their fireside talks about regular expressions. Highly recommend checking it out as he gets to go into more complicated regular expressions as part of that, mostly around version numbers for software. Regex 101 is a great place to test your regular expressions and see if they work, because you can put in not only your regular expression at the top, but you can also throw in some test strings to try it out and see what it finds and what it doesn't. Lastly, regular expressions are something we talk through and teach in the Jamf 400. So if you're interested in seeing them in a more classroom setting as part of some of the tasks we'll set you, and you want to learn more about them, feel free to take the Jamf 400 as long as you've taken the 300 and the 200 before that and qualify for the 400. But again, highly recommend. Thank you very much for your time today. We greatly appreciate it, and enjoy the rest of the conference.